All right, everyone, let's get back to the again reflection coefficient over here. We were talking about in the last part. So again, we said that if your reflection coefficient would be 1, magnitude would be 1, if you have short circuited the load or open circuited the load. Let me explain a little bit more what I meant with that. So let me bring back one of that over here. Let's say that you have short circuit. So then your reflection coefficient would be short circuit, right? ZL equal to 0, negative Z0 over 0 plus Z0, right? So you basically have negative 1. So negative 1 means if you try to match with this equation over here, so I have a magnitude, so magnitude is 1, then to get the negative sign, it would be negative plus minus J 180 degree, right? So then what is that? Let me explain what is that. So 1 is basically saying that you have cosine 180 degree, right? Plus minus over here J sine 180 degree, right? So if you do that, it's gonna come back to the negative 1. That's what it is. So that's same back over here. So this is saying that you have a magnitude of 1 and your angle could be either positive or negative 180 right here, right? If I do the same thing for your open circuit, when ZL is really big, so it doesn't matter, it's just become plain 1, because Z0 is irrelevant, then it's basically 1 J 0 degree, right? So that's it right here. So you have angle of 0 degree. So magnitude is 1, angle is 0 degree. Then if you, these things, to explain this thing over here, we need to do again same thing where we can do the same thing mathematically. Before I get there, let me do an example for you on this, then you will understand more. So again, deflection coefficient is basically big gamma over here is take the ratio of reflected component divided by the incident component. All right, so before I get to the next lecture, let me do a quick example for you. Let's say I have a transmission line coming in and connected a load of 50 ohms, and you have a C capacitance is 10 picofarad. So that's your ZL, right? So if I do the ZL over here, ZL would be your let's say 50, right? Negative J omega CL, right? You all know that equation there. So that is 50 minus, I'm going to put the J on top here. So it's 2 pi F, that's frequency is given, frequency is 100 megahertz times your 10 picofarad is 10 to the negative 11. So that's your GL, right? So now if we use that GL and is Z0 over here, that's given by 50 ohms, right? So I'm trying to find your reflection coefficient. The reflection coefficient would be again ZL minus Z0, right? And ZL plus Z0. If I use this math over here, so let me get the value for that one. So that is 1 over 2 times pi times 10 to the negative 3, enter, that is 159. So is 50 minus J 159, right? Negative 50, right? Then over here you have 50 minus J 159 plus 50, right? So now if you do the math correctly over here, let me do on my calculator here. On the top I have only one thing. I have negative 159 I. Your calculator should have an option for I if we're using any scientific calculator. Then over here I have 100 minus 159i. If I do the math here, my math says that I should get negative, negative 0.76 exponential j1193 degree, right? So let's see here. Oh, sorry, Z0 is 100. Sorry, I'm did a mistake over here. Z0 is 100. Okay, let's correct it. So Z0 is 100. Z0, oh, not this one, not this one, not this one. Z0 is 100 here. That's where we get the answer. Okay, that's if you do that, you should get this answer. So what is saying over here? It's saying that your reflection coefficient, value. So now over here, to get rid of this negative sign, over here, you have to add exponential j1 negative 180 to it. So to get rid of this negative sign, let me put over here 6 exponential j119 degree, and you can put j180 degree over here to get rid of negative sign. So if you do that, that means your reflection coefficient 76, all right? Then your theta r, if we add them together now, that would be 60, negative 60.7 degrees. So that's what two things over here, right? We're going to learn more about it in class 2 when I go to the example. I'm just trying to give you a quick example how to find your reflection coefficient and also reflection coefficient angle, okay? All right, so this is the end of lecture 5. We're going to go to lecture 6 in next video.